Let's look at problem 1, 2, and 3 real quick. Problems 1, 2, and 3 are all the same problem basically. If you drop something from a certain height, can you tell me how long it takes to hit the ground? In this case, we're talking about a bullet. And recall that if a bullet is moving horizontally, like a bullet coming out of a gun flying at 300 miles per hour, it doesn't matter that the bullet is moving. All we're concerned with is how long does it take that bullet to fall. And the formula T is equal to square root 2y over a will solve that for us. Problems 4 and 5 saying knowing how long it takes a bullet to fall. In the case of number 4, it takes 1.41 seconds. If we know how long it takes the bullet to fall and we know how fast the object is traveling horizontally, we can solve for how far it goes. Now again, in the x direction, in the horizontal direction, if the bullet is going 450 meters per second, it will always go 450 meters per second in the horizontal direction. So all we have to do is use velocity equals distance over time. Again, there is no acceleration in the x direction. The only acceleration is downward because of gravity. And you can see how we do number 4 and number 5. Number 6, same type of problem. From problem 3, you determine the time it takes the bullet to fall is the golf ball to fall is 2.26 seconds. So if we know how long it takes the golf ball to fall, and we know the golf ball's speed is 155 meters per second, we can calculate how far the golf ball goes. Number 7 and 8 are the same types of problem. The only difference with 7 and 8, I did not have you solve for time in an earlier problem. So let's solve for time in number 7. The time it takes for a baseball to fall from a height of 1.5 meters is 0.55 seconds. Use that and throw it into the D equals V times T, and you can tell how far the baseball goes. The same thing with number 8. How far from the base of a cliff will a car land if the cliff is 25 meters tall and the car is going 85 miles per hour? The first thing we have to do is figure out how long the car will be in the air, and we simply use T is equal to the square root of 2y over a. Again, if a car is falling from a cliff, acceleration is acting on it in the y direction only. Then we have the car going 85 miles per hour. We convert it into meters per second, which is 37.1 meters per second. And we can simply use our velocity formula, V is equal to D over T, to solve how far the car goes from the ground, from the base of the cliff. Number 9 is a little more tricky. It's mixed up. How high above the ground will an archer have to position herself? So I want to know how high up she has to be standing. Well, I have to figure out how far her arrow went, which was 85 meters. If it went 85 meters at a speed of 105 meters per second, I can determine what her time was. And the time was 0.81 seconds. So if it takes 0.81 seconds for something to fall, I can throw it into the cliff formula to figure out how high above the ground it was. Number 10 is basically another mixed up problem. You don't have time. Can you figure out how much time it takes Dan to fall from a height of 8.2 meters? Yes, it takes 1.29 seconds. If it takes 1.29 seconds, that's the time in the air. Can I determine Dan's velocity with D over T? I can. So there's the answers.